Okay, so let's see. Maybe it's this Microsoft Edge. Come on. All right. All right, we'll just try this. Okay, let me zoom in here. Okay. So we'll start talking about data structures in R. Okay, and so we have there's kind of like homogeneous data types and heterogeneous data types. Okay, homogeneous means all of the elements inside whatever you're storing is of the same type. Okay, and so if it's a one-dimensional thing where things are just kind of in a line and they're all of the same type, that would be what we call an atomic vector. Whereas if you have different types in there, then it's suddenly a list, okay? Or what we might call a generic vector. Okay, so if you ask R, is it a vector? If it's one-dimensional, it's going to say yes, whether it's an atomic vector or a generic vector. Whereas when we kind of just use the word vector in when talking about R, we're often thinking about atomic vectors, and then we'll call these things lists. But if you ask R the question, is it a vector, it's going to say yes to for either of these things. Okay. And then we have two-dimensional things, okay, basically things that look like rectangles. And if they're all of the same type, it's a matrix, okay? Or if you want to do a matrix, that another way to think of it is that everything in the matrix has to be of the same type. And if you want a rectangle where you have different types, where you have character data mixed in with numeric data or something like that, then it has to be a data frame, okay? And then you can have more than 2 dimensions. You know, you can have these arrays. Kind of, you think of these kind of like the 3D tic-tac-toe grid type of data, and those are arrays. And that only exists for the homogeneous vector types. Okay. Okay. As far as the vector types go, all right, we have the question we might want to ask as for the atomic vectors is what type of data is this, okay? And it will tell you the data you have is logical, or it's double, meaning it's some kind of numeric thing, okay? Or it's integer, or it's character, okay? And then we also have complex and raw. We're not going to worry about complex and raw. Complex data exists if you're dealing with imaginary numbers, but in data analysis, I've never encountered imaginary numbers in my personal data analysis. I mean, you know, I only have a few years of that, but I've never encountered it. But it, you know, R can handle it. Okay, and then raw. This is like it's like how memory stores thing in like assembly, and it's like in hexadecimal and stuff. And I don't think we're really going to deal with that. Okay, you can ask. Basically, you can ask R what is what type of data it is. Another question is mode. Okay. Although mode will just say numeric for both double and integer. Okay, so double meaning it's got like decimal places, and integer meaning whole numbers only, right? So R is, if you ask the mode of that stuff, it's going to just say numeric here rather than double or integer. Okay, and then there's storage.mode, and this is kind of like an older command. from the days of S. Okay. Did anyone tell you about the history of R? I don't know if this is anything that has interested you at all. Okay, so so back in the day, like in the 80s and 70s, there was Bell Labs. Okay, so Bell Labs is kind of like so Google today is probably what Bell Labs was 40 years ago. Okay, so you have a lot of cutting edge research coming out of Bell Labs, all related to the telephone industry. Okay, and so a lot of statistics and a lot of, the programming language C was invented by Bell Labs, and the programming language S was invented at Bell Labs. And S was for kind of had a statistical focus, and C had more of a computational computer programming focus. So anyway, that was developed back in the day, and then R came about kind of as a based on the language S, but to be open source, and so that was R was developed with its roots in S. But I don't know if you guys care. Okay. Anyway, so some of you guys are hoping to get jobs at Google because you can do kind of this computer research and all sorts of stuff, and so probably like the Google Labs of today, and Microsoft Research, and all of these computer tech firms that are kind of advancing the field of computer science and stuff. These ventures are comparable to what Bell Labs was 40 years ago. So okay, so we have atomic vectors. They're homogeneous. They must all be of the same type. Okay, and so we'll start off with kind of the you wouldn't call it a hierarchy, but kind of like this class system. So we have logical vectors where it's either true or false, or NAs, I guess, also count as logical. And so you can type into R, what type of, and then you give it the value true, and it will say this is logical type. Okay, and then if you I'm assuming you guys all know the command to create vectors using C to kind of combine elements together. So if you create a vector false, 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 and you ask what is its type, it's going to say logical. Okay. This is you should get into the habit of typing out the word true and false, the whole word in all caps. Okay. Don't. I strongly recommend against using just the letter T or the letter F, because using the letter T or F, R is smart where if you give it the letter T, it will treat it as true. But let's say somewhere you're doing some programming or something, and you create a variable called T, okay, and it's like to keep track of time or something like that. And then somewhere in that you set time equal to 0, T equal to 0. And then now suddenly all of your commands that have used T is going to start seeing the T as a 0, and that's going to have problems for your analysis. Okay, so you should get in the habit of typing out true or false completely in all caps. Those are reserved words in R. They will always have the logical value meaning of true and the logical meaning of false. It can never be anything else. Okay. So that's logical types. Character. Obviously, character data you can type in words like hello or the names Adam and Bob and things like that, and those will be of type character. Okay. So anyway, this is our markdown here. It shows you like this is what I typed in. This is the command that I've typed into R. And then this is the actual R output that says, if I ask type of, quote, hello, it will say character. Okay, and you can test this out yourself on your computer if you want. Okay. All right, double is the default numeric type. So anytime you give R some numbers, it's going to treat it as double. Okay, you give it 1.33, it's going to see that as a double, type double. Okay, if you give it the number 4, it's going to see that as type double. Okay, and if you give it 1, 2, 3, even though we recognize these as integers or the natural numbers or whatever, R sees this as type double. Okay, and that's fine. Okay, there's no real problem. Double uses a little bit more memory than integer type, but we're talking about like you know, 2 bytes versus 1 byte or something, you know, like just very these tiny differences in memory, which is negligible with our modern computing power. Okay, on the other hand, we have integers, which is also a numeric type, but R will recognize these as integers. If you want to say this is an integer, you've got to give it the capital L. Okay, so 1L will tell R this is the integer 1, and not the number 4, not the number 1 of type double. This is integer type 1. Okay, and I think most of us are familiar with using 1:3 or 1:20 to get the numbers 1 through 20 and things like that. When you do that, it comes out as type integer rather than double. Okay, does this have a huge difference in our day-to-day lives? Probably not, but sometimes when you're programming and you're expecting certain types to appear in your results and things like that, it could be a little bit, the answer may be a result of our handling the values this way. Okay, so you know, be familiar with all of this. Okay, all right, the command C or the function C combines elements together. So you put 1, 2, 3 together and it creates a vector, atomic vector, with the values 1, 2, 3, the characters here, and it does that. And when you if you nest a combine inside another combine, it just flattens it. Okay, there's no hierarchies in atomic vectors. It just goes, okay, 1, 2, 3, 1, 2, 3. Okay, so there's no difference between this and this. They are exactly identical in R's eyes. Okay. So you can always ask R, what type of data is this? Okay, and it's going to tell you, you know, this is double or character or whatever it is. But then you can also, if in your as you're writing functions, if you just want to make sure you're getting the data of the proper type, you can just say, is it logical, or is dot character, and things like that, and that will return true or false. Okay, is dot numeric will return true whether it is double or integer. Okay. All right, is dot integer 3, what is this going to say? False, right? What is it? Double. Okay, is dot integer 3 through 6? True. Is dot numeric? True. Is dot double? False. Okay, yeah, true, true, false, true, true, false. Okay, there you go. Okay, is dot atomic is you know, is it an atomic vector? If we ask, is it vector, it will return true if it's a vector or a atomic vector or a list. Okay, oftentimes when we talk about vectors, we're thinking atomic vectors, but you can't ask R, is it a vector, because it's going to say true whether it's even if it's a list. Okay. There's this thing called coercion where R is going to try to do what you ask of it. Okay. I like R. R is a great language, but I think so. There's a quote that says, you know, the best thing about R is that it was created by statisticians, and then the worst thing about R is that it was created by statisticians, and that it does a lot of funny things that computer programmers are not happy with. Okay, like in C, there's very strict rules. If you're programming in C, it's like you got to declare this variable is going to be this type, and if you try to plug in an integer into type double, it's going to get angry, or if you do something else. R is just like, you want me to do that? I'll do it, okay? And it's going to try its best, all right? So, you know, if you say combine, this is type double, right? The number 1 is type double with the character type hello. It's going to say, okay, well, I can't convert hello into type double, but I can convert 1 into type character. So there you go. Okay, I got character 1 and hello. False and the integer, it's going to coerce false into a value, integer value 0. Okay, and then, you know, you trying to combine type double with type integer, it coerces the integer into a type double there. Okay, so this is nice because you can just kind of type along and do things, and this is very useful, right? So some people, like strict computer programmers, might hate this about R, but this is actually a fantastically useful thing to do, especially, you know, when we're talking about subsetting. You can coerce things into take the result of a logical vector. You can just say, hey, I want you to calculate the mean of a bunch of trues and falses. R is going to say, okay, I'll do that for you. I'm going to convert all of the trues into ones, all of the falses into zeros, and now I can calculate the mean of that, which is going to give you basically the proportion of trues in the thing. Whereas, you know, other things will just, you would require extra steps, whereas with R you can just do it in one command. Okay, so it goes, okay, from the looks at the least restrictive form and coerces it into that form. So logical is most restrictive, then it will get coerced into integer, then double, and then character. Okay, so this is logical, this is integer, this is double, and this is character. And if we were to coerce the logical, integer, and double together, it will all get coerced into type double. Okay, whereas if we threw in the logical, the double, and the character together, it will all get coerced into type character. And so notice that the true, false, true, when it gets coerced into double, turns into 101, whereas the true, false, truth, when it gets coerced into character, gets all turned into character. Okay, in one step. Okay, so it just says, okay, the least restrictive type is the character one, so we're going to go straight there. It doesn't do a process where it goes, okay, I'm going to coerce the logical into a double and then convert that into character. It just goes straight to that. You can kind of manually coerce things yourself with the command as.numeric. Okay, and again, this is kind of what I'm talking about. You've got a vector of logical values, and you can do a sum, add them up, and it coerces them all into numeric. So it's false, false, true. They get coerced into zeros and ones right when you do sum of x, and right when you do mean of x. They get coerced into zeros and ones, and you can see the sum and the mean of those things. Okay, so coercion often happens automatically. It's a very great thing. Okay. There's explicit coercion, where you can kind of force things, and that might not make sense to us, but we can force to say, I want you to take this number 5.2 and coerce it into a logical value. Okay, and this basically says if it's a 0, it's going to be false, and if it's anything else, it's going to be true. All of these things, if you're going to do explicit coercion, I strongly recommend that you look up the help and test this out yourself to make sure it's doing the thing you want it to do. Okay, we don't often use this, but I would not feel like I've done this topic justice if I didn't mention this. Okay, so that's all of this stuff, and so it'll do the best it can for certain things. Like you say, take this character vector 7.2, coerce it as a double, and it will do the best it can, and it says, okay, I've created the number 7.2, but then if you try to coerce the character ONE for the word 1, it says, I don't know how to coerce that into a numeric variable, numeric value, double, yes.
Does add numeric produce double or integer?
As dot numeric, I'm going to say it produces double, but I guess I can test that out. But we gotta keep trucking along here. Okay. If any of this stuff I'm going too fast, or if you hate this, just let me know. Okay, if I'm going too fast or you need me to slow down. I'm trying to cover as much as I can on this. A lot of it is covered in the reading as well. So make sure you do your reading. Make sure you have a good grasp of this. This is having this internal knowledge in your head is going to be what distinguishes you from a proficient and capable R coder to someone who just kind of dabbles in R. Okay. Missing values are of type NA. Okay. They are not type NA. They are represented by the letters NA. Okay. It's a logical type. Why would we have NA be a logical type? Well, NA is logical because logical is the most restrictive form, okay? And you can have missing values of Boolean or logical values, right? You can have true, false, and you can also have missing. And so if we were to combine NA, if NA were of type character or something, and we were to throw an NA into a logical vector, it would coerce that vector into type character, and that would give us problems. So it makes sense that NA would be of type logical because it's the most restrictive, okay? If you try to add values to NA, it's going to say it's still NA. But notice that because I've added the number 1, it has now coerced the NA into type double. Okay. All right, we've got other numbers, not a number, positive infinity and negative infinity. If you try to do things that you're not supposed to do, like divide by 0, R is going to try its best, but it's going to say maybe. All right. If you get a NaN somewhere in your... so sometimes when you're coding and you ask for like a mean or something, or if you ask for it to do a calculation, it might return not a number, NaN. And that probably means you've tried to do something illegal, like add a positive infinity or subtract a infinity or something like that, okay? I don't know if we have time for this, but sure, we'll try this. Okay, what is this going to give us? Type character, and it's going to be 1, NA, and C, right? And 1 will be coerced into character. Okay? Yeah. I'll let you guys look at this on your own time. Okay? If we take the logical, the integer 1, divide by 0, that's going to give us positive infinity. We're also going to combine it with an NA. And so we'll see what that is. Okay? So this is type character. This is a type double, and all of this other stuff. Combining things. Here we go. Okay. When we add things together, okay, or multiply things together, a lot of these operators, such as addition or subtraction, work element-wise. So if we do 1 through 4 plus 2 through 5, it's going to do 1 plus 2, 2 plus 3, 3 plus 4, and 4 plus 5. Okay? And so you get 3, 5, 7, 9. Okay? 1 through 4 times 2 through 5, it does 1 times 2, 2 times 3, 3 times 4, and 4 times 5, and so we get 2, 6, 12, and 20. Okay, so these are element-wise. I think you guys probably have experienced familiarity with this already. I'm anticipating if you've taken stats 20. Okay. Do you guys recall how the recycling works in R? Maybe you've encountered this also, okay? So let's say we have the numbers 1 through 4, and we're asking it to multiply by the atomic vector 2 through 3, okay? So what this will do is it will go 1 times 2, 2 times 3, and then when it gets to the 3 over here, it recycles the 2 and the 3, okay? And then so it goes back to the 2, 3 times 2, and then it multiplies the 4 times the 3. So our resulting vector is going to be 2, 6, 6, and 12. Okay. It will recycle things, but it might return you a warning. Okay, so it goes 1, 2, 3, 4 times 2, 3, 4. It says, okay, I'm going to go 2, 3, and 4. So the 2 will multiply 1 by the 2 times the 3, and the 3 times the 4. And when it gets to this last element, the 4, it's going to recycle. It's going to recycle this back around and go with the 2. But then it says, wait a second, there's kind of a mismatch, right? I'm getting the longer object is not a multiple of the shorter object, okay? So it's saying, maybe you made a mistake. I'm going to do this, but maybe you made a mistake, okay? And there you go, okay? So sometimes maybe this is what you wanted it to do. Maybe it's not, okay? And so R will give you warnings. It's not going to error out. So if you have this inside a function, it's going to just go through with it. It'll store a warning and say, I'm not sure if this is what you wanted to do, but I'll do it, okay? And that's recycling, okay? So far, so good? Okay. We'll talk about lists then, okay? Lists are generic vector types, okay? They are one-dimensional, but they can contain all sorts of stuff, okay? So we can create a list, okay? And here I've got character, logical, double, and a function here, okay? Which is something we haven't even talked about, but they all exist in a list here, okay? And the list gets formed with double bracket 1, and inside double bracket 1, the first element is A, okay? And we've got double bracket 2, which has true, false, double bracket 3, which has these type doubles, and double bracket 4, which has the function in it. Okay. When you have a list, you can ask for its structure, okay? And then it will say there's four things in the list. You've got a character, a logical, numeric, and a function. Okay. And lists can be nested inside lists. Okay. So whereas with the atomic vectors, if we tried to nest a vector, atomic vector inside another atomic vector, it just flattened it out and said you are now part of the chain and you are in the atomic vector. With a list, it preserves kind of the internal structure here, okay? So here I've got B as the list of 5 and 12, okay? And C is the list 13, and if I create another list made up of B and C, we see this thing forming, okay? So it says, here's the first element in list A, which is a list itself, which has 2 elements, 1 and 2. And then the second element in list A is a list of itself. If we ask what's the structure of list A, it says there's a list of 2, okay, which is what it is. We've listed B and C together. And then B itself, the first thing is a list of 2 with the numbers 5 and 12. And then the list is in here, number 3. Okay, and so it's important to realize that using the command list to create lists is going to embed lists inside of others. Okay, and so this is kind of you've got a clear hierarchy of how these things are created inside a list here. Okay, more of this stuff. So here X is a list with 1 and 2, but then here I'm not using the command list, but just combine, so we're throwing in an atomic vector here. And so it's a list of 2 where we've got 1 and 2 inside here, and then the atomic vector 3 and 4, okay? Whereas if I looked at Y, where I've combined a list of 1 and 2 and the atomic vector 3 and 4, what does it do? It tries to coerce this stuff, the 3 and the 4, the atomic vector, into a list. And it says now Y is just a list of 4 with the values 1, 2, 3, 4. Okay? So these are just kind of some odd little things that that R will do when you you know, if you use combine versus list to kind of stick things together. Okay, so be aware there. All right. Okay, we can name things in the list, so we can say, you know, here's A, here's B, and C, and D, and E, and all of these things, and so and they show up with the $sign to indicate this is how you can ask for the elements inside a list. Okay, so our example here is a list, and we can say example $A, and it will return atomic vector with 1. Okay, because this is the contents here. Whereas, and then we can ask for B, and when we ask for B, it's going to return this list of 2 and 3, okay, with the elements C and D, okay. But if we ask examp $C, it's not inside the first order hierarchy here, okay, and so it's going to say I don't have anything there, okay. But if we want to get to this number 2, we have to say inside the example list, I'm looking at element B, and inside element B, I'm looking at element C. And then it will say, oh, you're talking about this thing, the number 2 there. Okay. And then if we just ask $E, it's going to give me back 4, 5, 6. Okay. Okay, we have attributes. Attributes are just arbitrary kind of additional information that can just be attached to some object in R. Okay, so it's just like taking a Post-it note and scribbling down some extra stuff and then taping it onto or sticking it onto whatever object you have in R. Okay, and so you can attach any arbitrary attribute that you want to any object, really. Okay. Now a lot of objects come with kind of its own basic set of attributes, right? If you have the names of something or its dimensions, those are kind of attached to the object by default. But you can throw on some extra things. Okay. So here. X is going to be a vector, atomic vector, with numbers 1, 2, and 3 in it, okay? And we are attaching names to those things, L, M, and N, okay? And so if we ask, what are the attributes of this object X, it will say, oh, you've got names, L, M, and N, okay? And if we ask R, you know, what is this thing, attributes? What exactly is attributes? It's going to say, oh, what attributes of X are? It's a list, okay? It's a list. Another way to get particular attributes is you can use the attr function and say, give me the attributes corresponding to this names, okay? And it says, okay, well, those are L, M, and N, all right? So attributes of X $names, it would be the same thing as this. Okay. Okay. you can say, what I want you to do is I want you to take the letters A, B, and C, which can be a shorthand way of getting that is using the built-in atomic vector letters, and say I want you to take the first 3 letters in A, B, C, and I want you to reassign the attributes of X of names to letters A, B, and C. And we ask, what is X now? It's going to say it's 1, 2, 3, and they are their names are now A, B, C. Okay. And then again, we can just attach any arbitrary attribute. Okay. So names are kind of like a thing that R finds useful, and so it kind of defines these things for us. But then if you want to just make up something called my attribute, or like whatever other information that you have, okay, you can just throw it in there. This is like the post-it note that you are now attaching to the object X, okay? And we say, okay, what are the attributes of X? And it says, okay, well, I've got the name information, and then I have this other post-it note that just says, this came attached to the vector here, and it says this is a vector, okay? So you can just throw in, whatever you want to attach, you can do it via the attributes, okay? It's just like throwing on extra information with a post-it notes, okay? When you modify a vector, okay, a lot of these attributes are lost, but these 3, names, dimensions, and class, these are not, because they are important, okay? So we've got dimensions, they can turn vectors into matrices and arrays. Class is part of R's object system. So there's like S3 and S4. This is how R handles its object-oriented programming stuff, and it uses class. Okay. Again, sometimes it's easy to just ask what is the class of something, but if you're asking for exactly what the vector is, the command you want to use is type of. Okay. So so these things are all equivalent. Asking the attributes of X that are associated with names is exactly the same as this command names of X. Okay, it's dim in class as well. Okay, so we can say, what are the attributes of X? Okay, now if I subset X using bracket notation, just give me the first element of X, it would be, we notice that this attached attribute is lost. Okay, so the my attribute that this is a vector, that post-it note, that gets lost when we subset or something like that. Okay, there are as far as names go, you can name a vector in a few ways. Okay, you can name it when you're creating it, ABC. Okay, you can modify an existing vector. All right, so you can say, here's X. X is going to be integers 1 through 3, and then what I want you to do is I want you to throw in into the attributes names. What do you call it? ABC. Okay, or you can take some vector and use the command set names and set the names ABC. Okay, and the output of this is going to be something new, and it's basically creating a copy. Now you could set the output to X and it will overwrite. It's creating a copy and it will overwrite the X. Okay, but that is essentially a little bit different from this one, because this one you are kind of modifying the names attribute here, and here you're creating a new object and you're storing it somewhere else. Okay. Names don't have to be unique, but when we do character subsetting, it's most useful when the names are unique. Okay. And you don't need to have names for everything, and if you have something in there that's not named, it's going to say the names will return null. Why don't we just stretch for a second here? All right, so we'll continue on here with names. Okay, we also have factors. Okay, so one thing is we've got factors, and they're kind of like it's a special type of vector where you are only allowed predefined values here. Okay, so here we're going to take kind of this character vector a b b a. Okay, and we're going to say this is a factor. Okay, and when we ask for x, it's going to tell us a b b a, and it says the only values allowed in this factor are a and b. Okay, and if we ask, what is the class here, it says, okay, it's a factor. But if we ask what is the type of, it tells me it's an integer. Okay. And that might seem odd because it sure looks like character data here. Okay, and actually when we take this thing that is character, this really is character data, but we throw it into the command factor, it gets turned into an integer. Okay, and so underlying this, if we were to ask what this is, if we were to print it as an integer, it would actually just be the numbers 1, 2, 2, 1. Okay, and levels, which is an attribute of x, the levels are the characters a and b. Okay, so if we were to say, if we wanted to replace the second element in x with the character c, it's going to say that's not allowed. Okay, and it says you've got a missing value, b, and a. All right, and then and if we were to just try to combine things, okay, if we turned factor a, the letter a into a factor and b into a factor here first, and then combine them, then it doesn't understand what you're trying to do here. Okay, if you wanted to combine things together, you've got to combine them first and then feed them into a factor here. Okay, it's an interesting choice of ringtone here. All right. All right, so factors are useful. Using a factor instead of a character makes it obvious when some groups contain no observations here. Okay, so if we just left the character vector as m, okay, here, and we created a table with it, okay, it will say, okay, you've got 3 that are classified m. Okay, whereas if we were to take this and feed the character vector for sex into a factor, and we say there are 2 levels, male and female, then it creates a table where it says there are 3 under the factor m and 0 for f. Okay, and then this is just a simplified example. Okay, I know the world is maybe not dichotomous here. Okay, and so anyway, a lot of times you encounter factors when you read data into R. So if you used something like read.table or read.csv, its default thing is to take characters and feed it into a factor. Okay, or it says you're expecting a numeric vector, and somehow it's producing a factor, and you're wondering, what's going on. Okay, oftentimes you've got missing data in that column, and the way you've stored your missing data maybe is using a dash or a NA or something, something like missing, and R sees this as, oh, this isn't all just numeric data, it's you've got something else going on here, and so it turns it into a factor. Okay, The default setting is strings as factors is true, okay? You probably want to actually throw in the argument strings as factors equal to false, unless you know the column you have actually is a factor, something where there's only predefined values. But a lot of times, now that you know, we've got all sorts of other types of data, character data is often not a factor, but rather, you know, it's like a tweet or something. You know, it's got character information that's not necessarily confined to just a certain set of values. Okay, if it is character data that's confined to a certain set of values, say the manufacturer of a vehicle, then it makes sense to use factor. Otherwise, you probably want to leave them as characters. Okay. And you know, further notes on factors versus characters. They look like character vectors, but they're actually stored as integers, right? So we said, you know, type of, you know, some factor vector thing, and it's actually an integer, all right? And so certain things, you can coerce these factors back into characters and whatnot, but a lot of times they are stored with an underlying integer values, and so that might throw off what you're trying to do when you're writing up some code. Okay. In Stats 20, did you guys do regular expressions? Yeah. Okay. With like and like rvest and stuff like that. Okay. I have that scheduled, but you know, maybe we'll spend less time on that. Okay, so moving on to our two-dimensional data types. We've got matrices and arrays. Okay, and so we can use a dimension attribute on an atomic vector. Okay, and then it will suddenly coerce it, or not coerce it, but just turn it into a matrix, okay? And actually, that's actually all a matrix is. A matrix is really just a atomic vector with a dimension attribute, and because it's got dimensions attached to it, R now treats this as a matrix, and the code underlying R is very efficient at handling matrices and doing multiplication with matrices and vectors and things like that, okay? So here is here's a command to create a matrix. I'm giving it an atomic vector, 1 through 6, 1, 2, 3, 4, 5, 6, okay? But then I'm attaching, I'm saying I want 3 columns, 2 rows. The number of rows is 2, number of columns is 3, and so it creates a matrix, and it's taken the values 1, 2, 3, 4, 5, 6, and it's created it into this rectangular format here. Okay. Okay. Here you can do the same thing three-dimensionally. Okay. Take the array 1 through 12. I mean, take the atomic vector 1 through 12. Create an array with it using these dimensions 2, 3, 12. Okay. And so it basically says you want 2 rows, 3 columns, and 2. I don't know. You got rows, columns, and layers? I don't know. Something, okay? And so you have this, and it says, okay, so this is, you know, the first row, second row, first column, second column, third column, and then this is like our first layer and third layer. And so you can see how the way it populates the thing is goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay? Better make sure my phone is silenced too. Sometimes my phone, lately, somebody will call and I can't answer it and I can't hang up, and anyway, life is hard, right? Okay. You can also modify a object just by changing the dimensions attribute, okay? So here's, this is probably bad manners to call something object C, but I did anyway. You've got the elements 1 through 6. This is an atomic vector, and then I just modify it by using the dimensions attribute and say I want 3 rows, 2 columns, and it says okay, you got it, and I've now made a matrix. Okay, and then you say okay, wait a second, turn this back into 2 rows, 3 columns, and it says okay, I've done it. And we're modifying this object. This object, R sees it kind of as a atomic vector with dimension attributes, and so it can change the dimensions on the fly here. This is probably not the most recommended way to do it because it's easy to make mistakes, and it's, you know, unless you're very good at this kind of stuff, it's easy to kind of forget where things go in the columns and stuff. But this is kind of how R sees the data. Okay? Atomic vector with dimensions. Okay. You have the length attribute for atomic vectors, which tells you how many elements you have in it, and then you have for matrices you've got the number of rows and the number of columns for how many rows and columns you have in a matrix, okay? And you can also attach names, okay? So if it doesn't have any names, it just kind of says 1 comma to indicate the first row, and then comma 1 to indicate the first column, okay? So, you know, when you subset in R, and we'll talk about subsetting in just a minute here, you know, it's always row, comma, column, and so bracket, comma 3 will give you this column here, okay? You can attach row names, A and B, column names, A, B, C, so on and so forth, and it's just a matrix or atomic vector with dimensions and row name and column name attributes attached to it. Okay. And so notice all of these things. When we ask for the length, it says 6, but the number of rows and the number of columns are 2 and 3. Okay. B is an array, 3-dimensional array, but if we ask for its length, it says there's 12, right? The dimensions of B are 2, 3, and 12, and then we can attach dimension names to it, much in the same way as row names and column names, but because it's 3-dimensional, we got all of this. And there, it does it for us. Okay. Okay, we have C bind. Okay, so if we've got, so looking back at what A is this matrix, 2 by 3 matrix, and C bind is you're binding column wise. Okay, column binding. Okay, and so basically says bind the columns of A to the columns of A, and you got two A matrices side by side. If we did R bind, you're binding the rows. You're going to basically be stacking the matrices on top of each other. Okay, and it goes, you know, one matrix A stacked or binded to another matrix A right below it. Okay, you can have one-dimensional matrices. That's a typo. And so one-dimensional matrix, so this is a vector, 1, 2, 3, but then we can, and the structure will tell us that, okay? So this is a one-dimensional atomic vector, okay? And if we ask the structure, it tells us exactly all of that. There's no attributes attached to it, okay? If we can turn it into a matrix with just a single column or a single row, and this is still one-dimensional, okay? Except if we look at the structure here, we notice that there are, it says 1 through 3, comma 1, rather than over here, it's just, there's no comma there, right? Because it's just an atomic vector, okay? The atomic here is also true, okay? The attributes of G it's got dimensions here, whereas before there were no attributes to the atomic vector, a one-dimensional vector versus a one-dimensional matrix. Okay, and this would apply whether it was a row matrix or a column matrix. Okay. Oh, here we are. This is a row, and again, similar stuff. It's an array. Okay. Okay, and then data frames are like lists now, except there are, so lists, you could have different types of data. Okay, with a data frame, you have a list, you can have different types of data, but now they are arranged in a rectangular form, like much like a Excel table or something like that. Okay, and this is probably our most common way of storing things. It's got a lot of things in common with you know, the matrix, like column names and row names and things like that. Okay, but this time the length attribute, okay, when you did the length of a matrix, it told you how many elements are total are in there, right? But because a data frame's underlying structure is a list, the length attribute will tell you how many list elements there are, which is basically the number of columns in your data frame. Okay. So here I've got I'm going to create a data frame. This is basically you can essentially think of this as a list, but now we're just saying arrange it into a table form. Okay. So I've got 1 through 3 as X and A, B, C as Y, and it's arranging it as in a table form. But if we ask the structure, we very much see the underlying list structure to it, right? It kind of has the same form with $X and $Y for the list structure here. Okay. Okay. Again, you get the strings as factors problem there. Okay. If we ask, you know, what is the type of for a data frame? It'll say it's a list, but the class is a data.frame, which just basically means it prints it out differently than the way it prints out a list. Okay. All of these things you can coerce into data frames. Okay. And certain things like cbind and rbind work fine. Okay, so you can, if we take our original data frame, which is 1, 2, 3, ABC, we can cbind it with another data frame with the elements 3, 2, 1. Okay, and it creates that. Okay, and you can rbind the same thing, 1, 2, 3, ABC, to another data frame where you've got X is 10 and Z in the Y column. Okay. So rbind and cbind work with data frames as long as you have them kind of the appropriate dimensions here. Okay, when combining column-wise, the number of rows must match. Okay, row names are ignored. When combining row-wise, the number and names of the columns must match. Okay, so here when we were doing the row binding, we have to say X is this and Y is this. Okay, whereas when you're cbinding, you didn't need to worry about row names. Okay, you just need to have the correct number of rows. Okay. And then this is a good warning. It's a common mistake to try to create a data frame by using cbind for vectors. Okay, and that doesn't work because cbind creates a matrix first, which means you're going to be doing a lot of coercion if you've got different element types. Okay, so just use data frame directly. Okay, so so if we were to do cbind 1 through 2 and A and B, and then put that into a data frame, it's coerced everything into actually factors here. Okay, which we don't want. And so here, just do the data frame directly. Do you guys use dplyr already? Yes? No? Okay. So dplyr is totally awesome, and we will encounter dplyr later. All right. And basically, dplyr handles data frames a little bit more nicely. Okay. We only have about 10 minutes here, so I'll probably have to. I'll get through some of this subsetting stuff, and we'll have to continue it later, or I'll leave it to you in your reading to get through some of the subsetting stuff. Okay. So subsetting is the idea that you've got an object with a lot of information in it, but you only want parts of it, okay? And so there are ways to just subset. Maybe you just want certain rows. Maybe you just want certain columns. There's all sorts of stuff, okay? So you can subset vectors, atomic vectors, using single bracket notation, okay? And then you also have lists, which can be which will use double bracket notation or the $sign. Okay. And sometimes when you use these things, there are defaults to simplifying the resulting thing by getting rid of the attributes that are attached to it, and we'll take a look at some of those differences. Okay. All right. We'll just take a quick look at the atomic vector stuff, and then that's probably all we can cover for today. All right. So here is there are 4 elements here, and this thing the place after the decimal indicate its position in the original vector here. Okay. So we got 2.1. 4.2, 3.3, and 5.4. Okay, and so there are kind of a few different ways you can subset a vector: positive integers, negative integers, logical vectors, and character vectors. Okay, so using positive integers, we return the elements in those specified positions. So we get the third and the first element. Okay, whereas the order says, what is the order in which kind of it's that needs to be applied to x, so that the elements go in order from least to greatest. Okay, so the order of x, if we look at original x, it says you should go 1, then 3, then 2, then 4, and this is the order in which you'll have the elements arranged from least to greatest. Okay. You can use the same integer there, or the same value there, and it will return the same thing twice. Okay, and if you have, if for whatever reason you're trying to subset on x and you give it a decimal place, they get chopped off and it just returns the second element. So here we got 2.1, it just ignores the decimal .1, or the 2.9, it ignores the decimal .9 and just returns the second element in that vector. Okay. With negative integers, it gets rid of those elements. So this will say, give me x, using bracket notation, give me x except the third and the first element. Okay, and it does that. Okay, but you can't mix negative and positive, because it says, well, I don't know. Are you telling me to ignore the first one, or do you just want the second element? And it doesn't know what you're trying to do. Okay. So so negative integers are useful if you're just trying to get rid of a few pieces out of there. Okay. Logical vectors will tell you basically they'll get recycled through. Otherwise, we had 4 elements, and it says return. Should I return the first element? Yes, true. Return the second element? True. Return the third element? No, false. Return the fourth element? No, false. So it's just going to return the first 2 elements. Okay. Is x greater than 3? This is going to be return true and false, and it's only going to return those which satisfy x greater than 3 as true. And so this is going to get rid of anything less than 3, which was that 2.1. Okay, and all of these things work in the same way. So again, there's the recycling. So it goes true, false, true, false. So you can imagine a vector with length 4, a logical vector that goes true, false, which means it's just going to return the first and third element, okay? Which is what we have here, okay? And if we ask for it to, if we give it an NA, it's going to return an NA here. Okay, why don't we'll take a break here, or we'll stop here, and then we'll continue on Wednesday here. I've posted your first homework assignment. I would recommend starting the reading from those textbooks tonight, okay? And I'll see you guys on Wednesday.